and waste management. And we've spent quite a bit of time talking about the kidneys and the nephrons and how they make the urine. But your kidneys do more than just filter the blood. They also have a regulatory function. So they maintain and regulate the volume of blood in your body. And they do this by regulating the water volume. So this is done by two hormones, ADH and aldosterone. So ADH stands for antidiuretic hormone. It used to be called vasopressin, so if you've ever heard of that. And anti means against, and diuretic means increased urine output. So if something's a diuretic, it will make you urinate or pee more. So if it's anti-diuretic, it'll be against peeing more, or you'll urinate less frequently. It's released by the pituitary gland, which is the master gland in your brain, and it promotes the reabsorption of water from the collecting duct. So if your blood volume is low, and your body regulates the blood volume by the blood pressure sometimes. So if your blood volume's low, ADH will be released, and you'll reabsorb more water. You'll have more water in your blood, more blood volume, and then more blood pressure. So it'll reabsorb that from the collecting duct and the distal convoluted tubule. So here's how ADH does its job. So cells in your brain, or your hypothalamus area of your brain detect low water content of blood. So antidiuretic hormone, or ADH, is released into the blood, and it acts on the distal convoluted tubule and collecting duct. More water is reabsorbed, so the volume of your urine decreases, but your blood volume increases. As the blood becomes more dilute, it's detected by the hypothalamus. It tells the pituitary gland to stop making ADH, so the ADH secretion stops. So this is a negative feedback loop, and your blood volume kind of remains stable. So if you were to look at this diagram of the nephron, ADH would act, and I've just started off here and got it in red, on that distal tubule and that collecting duct as well. Oops, goodness, sorry about that. Oh, goodness. I will just use the down arrow. Sorry about that. So diuretic drugs are prescribed to people that have high blood pressure. So it inhibits that ADH secretion, so it lowers the blood volume and the blood pressure, but it causes increased urination. So that would be a side effect of taking a diuretic drug. Alcohol also inhibits ADH secretion. So drinking alcohol therefore causes increased urination. Increased urination can cause dehydration, and dehydration is the primary cause of a hangover. So it's important to note that beer and alcohol cannot quench your thirst. You'll urinate more liquid than you'll take in. Just a side note. Inability to produce ADH causes what we call diabetes insipidus. So this actually has nothing to do with type 1 and type 2 diabetes mellitus that we've talked about before. Diabetes insipidus is a fairly rare type of diabetes, and it causes watery urine. So watery urine would be really, really light in color. And unfortunately, we're not going to be in class to do the fake urine urinalysis. I'm still working on kind of an online one. I'll at least give you some data to analyze. But if you were looking to diagnose someone with diabetes insipidus, you'd be looking at the color of urine. And if it was really light and looked really watery in color, that would be a good indicator that they are suffering from diabetes insipidus. So people with diabetes insipidus urinate too much, so they lose a lot of salts from their urine and blood ion levels drop. So the treatment for that is injections of ADH. Okay, so again, this little box just tells us that diabetes insipidus is different than diabetes mellitus, which is an inability to regulate our blood glucose levels. I'm sorry, I'm just going to scroll down to the bottom. I don't know what's, the Smart Notebook is going crazy. So hopefully that helps. So kidneys, in addition to filtering the blood, can also regulate the blood volume, and it can also regulate your blood pH. And again, I'm just going to erase this page number because I've updated your book in the COVID edition. So aldosterone is the other hormone. It's released by the adrenal cortex. So adrenal cortex are glands that sit directly on top of the kidneys. So when you did tasks 3, 4, and 5, one of those had a picture. I'm just going to flip in my book here. Page 16 had a picture of the adrenal glands. And I had kind of put that in, I had typed those in, it was B on task 3 on page 16. Those adrenal glands, they sit right on top of your kidneys, and I say they produce hormones. So one of the hormones they produce is aldosterone. And aldosterone acts on your kidneys to retain, that means keep, sodium ions and get rid of or excrete potassium ions. So you do need to know where the adrenal glands are. Make sure they're labeled on that diagram on page 16, but I labeled it for you because we weren't in class. So it regulates this concentration of sodium in your blood and in turn regulates the secretion of aldosterone. So this is another negative feedback loop. So sodium in your blood is important to kidneys' ability to reabsorb water. So again, when we talked about our urine formation, we talked about that increasing saltiness and that concentration gradient that's set up. So we need to have enough salt there because that saltiness in the medulla around that loop of surrounding that loop of Henle is why our water passively reabsorbs back in. So if the sodium in the blood is too low, too little water is reabsorbed and it results in hypotension, or hypo again means less or low blood pressure. If your sodium levels are too high, that results in that hypertension. Hyper is greater or that high blood pressure. Kidneys and your blood pH. So pH is the potential of hydrogen. So hopefully you remember your chemistry unit of grade 10. And on our pH scale, we talk about how acidic or how basic or alkaline something is. So the pH scale goes from 1 to 14 with 7 being neutral. So the acidic side, we have these hydrogen plus, these H pluses are hydrogen ions. And the basic side, we have these hydroxide or OH negative ions. So your kidneys help to maintain your blood pH along with your blood volume, along with filtering the blood. So your nephrons vary the amount of hydrogen ions and ammonia that they excrete. So those are the acidic portions, and the amount of bicarbonate, HCO3, and sodium they absorb. So bicarbonate is that base. It'll actually break up into carbon dioxide and that OH negative or that hydroxide. So this is what keeps your blood pH within normal limits. If your blood is acidic, more hydrogen and ammonia are excreted and more sodium bicarbonate is reabsorbed. Sodium bicarbonate neutralizes the acid. So you talked about neutralization reactions in grade 10 chemistry. So here's a formula for you. If your blood is basic, so alkaline, that's too high above 7, then less hydrogen ions are excreted and less sodium ions and bicarbonate are reabsorbed. So reabsorption of and excretion of ions by kidneys also maintains a proper electrolyte balance in your blood. That's all for today. In terms of your a task for today, you're just going to do task 6. So task 6 in your book. I'm going to update your questions in your lesson plan as to what questions to do, but we're going to break task 6 because it's fairly large into a couple of different pieces. I hope that's helpful. Take care. Take care.